Hello, scholars. Welcome to our lesson 5.02. And today you'll notice that our lesson title is very similar to our lesson from last time. Today we're focusing on multiplying a whole number by a fraction. Yesterday our lesson was about multiplying a fraction by a whole number. And you might be wondering, isn't that just the same thing? And in a way, it is, but there are a couple things that are a little different in the way we think about these kinds of problems. And so I'm going to walk you through those differences, but you're going to see the same strategies we talked about yesterday pop up again today. The strategies of using repeated addition, as well as top times top, bottom times bottom. Let's dive in, friends. So going into our lesson, I want to review the problem we looked at first yesterday. Hopefully you remember our cute puppy and his diet, where he eats 2/3 of a cup of food for every meal. And if he eats 4 meals, how much does he eat altogether? That was our question, right? And we talked about how we can use repeated addition to solve and find the answer. And in this case, we said, okay, well, 2/3 plus 2/3 plus 2/3 plus 2/3, that's the same as saying 4 times 2/3, right? I'll just write that right here. 4 times 2/3. That was the same thing as doing repeated addition. Both of those get us the same answer of 8/3, 8/3, which we simplified to be a mixed number, 2 2/3 a cup of food, all together in 4 meals. This repeated addition is showing us that 4 times 2/3, right? We're repeating or multiplying that fraction by a whole number. Now that's what we talked about yesterday. Today we're going to flip it. And we're saying now instead of multiplying that fraction and repeating that fraction, adding it over and over, we're going to think of it a little bit differently. Let's take a look at this story now to show or illustrate that idea. So in this story, there's a PE teacher, and he has 20 basketballs. He needs 3/5 of the 20 balls for a game to play with his class. How many balls will he use for the game? So you can see here we've got a whole of 20 basketballs. That's how many basketballs he's gotten all. And I'll just show our picture right here because we love a picture in math. That helps us break things apart, right? Now we also have a part. And that's 3/5 of the 20 balls. So we're talking about 20 balls in total, and he's only going to need a part of them for his game. 3/5 of those balls, right? Just a part. So let's talk about how we could figure out how many balls are going to be used in that game. Well, the first thing we're going to do, now that we have our whole showing our 20 basketballs, is now we want to break that whole into some equal parts. And we want to make sure that we're paying attention to the denominator in this fraction part right here, which is a 5. Now we know that the numerator tells us how many parts out of the whole we have, but the denominator tells us how many parts are in the whole when we break it into parts. So in this case, there's going to be 5 equal parts. This 20 basketballs is going to be broken into 5 different groups, 5 parts. So I've gone ahead, and now I've broken this into 1, 2, 3, 4, 5 equal parts, just like our denominator told us. He only needs 3 of those 5 parts. 3 of those 5 parts. So looking here, here's 1 part, this row here, 2 parts, this row here, and 3 parts, this row here. So if he only needed 1 row or 1 part, that would be 1, 2, 3, 4 balls. If he only needed 2 parts, that would be 4 in this first row, plus 5, 6, 7, 8. Now for 3/5, it's 9, 10, 11, 12. He will be using 12 balls for his game. And we know this because we broke this whole group of 20 basketballs into 5 equal groups. And out of those 5 equal groups, he only needs 3 of those groups. Since each group has 4 balls in it, it's kind of like saying 4 times 3, which we know is equal to 12. Let's look at this another way. So I'm going to keep our balls here onto the side, but I've also added in another way to look at this, another visual representation. So same story here. We've got the 20 balls, but this way we're showing it with a bar model. Here's our total. All the way across that bar is 20 balls. It's representing all 20. And we've broken it into 5 equal parts. 1, 2, 3, 4, 5 parts. Out of that whole 20, we've broken it into 5 equal parts. And he only needs 3 of those 5 groups. So those 3 are shaded in red. So 3/5 of 20 is the number that is 3/5 times as much as 20. Ooh, times is a key word here. 3/5 times as much as 20. And I'm going to draw your attention to one other key word here. Of. I'm going to circle it really big. Of is a very important word. In math, of means multiply. Write a little multiply symbol here. Whoops. Well, that turned out bad. Multiply. When we see the word of, or if we see the phrase times as much as, those are key words that tell us to multiply. So if we're looking at this, we say that 3/5 of 20 is the number that is 3/5 times as much as 20. That's like saying, I wrote a 2 instead of a 3. Let me start over. 3/5 times 20. Now, this is looking familiar to what we've done yesterday, right? I told you it's a little bit different in the way we're thinking about it, because now, instead of adding over and over and over a fraction, now we're taking a whole and we're breaking it into equal pieces and seeing how much of that whole is the answer. So in this case, we have all these pictures to help us understand why, but when we do the math, we can keep it simple. We can stick with what we know, which is our 2 strategies. We can either do repeated addition and say 3/5 plus 3/5 plus 3/5 20 times, or we can say 3/5 times, I'm going to rewrite it here, 20 over 1. Last time we talked about how any number over 1 in fraction is just that numerator as a whole, right? It's just another way of writing the equivalent fraction. And when we do this, it makes our life really easy because all we need to do is multiply across the top, top times top, and multiply across the bottom, bottom times bottom. So our top number, 3 times 20, well, that's like saying 3 times 2. That's 6, but we'll add our 0. Mental math strategies there. 60 over, and 5 times 1 is 5. Now from here, we could simplify this. And we could say, okay, well, I know that a fraction is the same thing as division. 60 over 5 is like saying 60 divided by 5. 5 goes into 60. Well, let's count. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Hey, 60 is a multiple of 5 because 5 goes into 60 12 times evenly. And if we subtract to find the difference, there is no remainder. So that means that this can be simplified into 12, which is the same answer we found on our last, when we were just going through this strategy. We said he would need 12 balls for his game. And we just found it another way, using strategies we already know. So I know I kind of broke it down and I showed a lot of different pictures and ways of thinking about it. And it's good to understand that. But the important thing to remember here is that you can keep it simple and use these strategies that we already know to help you solve without having to draw big pictures and stuff. Let's take a look at an example of that. So here, this is one's a little bit different, but we're going to keep in mind the same strategies because they still work. If you're looking at this problem, it says, find the number that is 4/3 times as large as, there's that key phrase we talked about here on this slide, times as much as. That means we're multiplying, right? So find the number that is 4/3 times as large as 12. When you see that phrase, you're going to think, oh, I need to multiply. So you're going to set yourself up and you're going to write your fraction 4/3, which we know is an improper fraction because the numerator is larger than the denominator. And if there's an improper fraction, that means that there's more than one whole there. There's one whole or two wholes or three wholes, depending on how much the number is. There's at least one whole and some extra. So we're multiplying 4/3 times as much as, or as large as, and we're going to write 12 as an equivalent fraction over 1. Now we can use our strategy here. This one I would not recommend doing repeated addition on because 12 times 4/3 is a lot of 4/3 to add over and over. So instead, I'm going to do strategy number 2. Multiply top, bottom times bottom. 4 times 12 is 48. 3 times 1 is 3. We automatically know this has not been simplified because it's an improper fraction. It can definitely be written as a mixed number, so I'm going to use my division strategy to make sure that I have this written simplified. So 48 divided by 3, and we're going to ask ourselves, okay, how many times can 3 go into 4? It goes in 1 whole time. Subtract to find the difference. Bring down our next digit, which is 8. How many times can 3 go into 18? Well, I know 3 times 6 is 18. And again, we find the difference, which is 0. So that tells us there is no remainder in this one. So this one we're going to write as just a whole number. 48/3 is just 16. Now see how we did this without any pictures? We were able to just use our multiply top times top, bottom times bottom strategy to get this done. But I do want to show you a picture to show exactly what happens when we multiply by an improper fraction when we're multiplying a whole number. So you can see here, whoops, sorry about that line there. Got a crazy pen going on. But when we look at this number, we see, okay, 12 was our whole. So here it is, right here. 1 whole is 12. Notice this part out here, that's an extra piece. That's more than 1 whole, right? Each one of these dark red sections is 1/3 times 12, or it's 1/3 of 12. So each of those dark ones, that is 1/3 of 12, which we know it's 4, right? Because 1/3 times 12, multiply top, bottom, and that equals 4. So each one of these is 4. 3 4s makes our whole of 12. But when we have 4/3, here's our fourth one right here. We have 4 of them. That is 4/3, and we can multiply 4 times 4, because there's 4 4s. We're going to add 4 times, 4 plus 4 plus 4 plus 4, and that gives us 16. So that's how that works if we want to break it down into the y. But the important thing to remember is just our strategies we've used before. It does not matter if it is an improper fraction or if it is a proper fraction that we are multiplying by a whole number. It doesn't matter. Either way, we can still use the strategies that we have learned. I want to look at one last example together. And for this one, look at the fraction. Is it a proper fraction or is it an improper fraction? For this one, it's an improper fraction. So now we're going to decide what strategy would we like to do. For this one, our whole number is small. So we could say 5/2 plus 5/2 equals what? And just do repeated addition only 2 times. I personally really like doing top times top, bottom times bottom. I think that one is the quickest and it works for every multiplication of a fraction times a whole number. Works every time. So I'm going to just stick with that one. But if you prefer the other method, you can do that too. So to set myself up, I'm going to say 5/2 times 2, but I'm going to write the equivalent fraction of 2, which is 2 over 1. And now I'm set up to multiply top and bottom. 5 times 2 is 10, and 2 times 1 is 2. Maybe at this point you're getting a little bit faster when looking at these improper fractions, and maybe you've noticed already 10 divided by 2, or 10 over 2, You might know that answer already. 10 divided by 2 is just 5. So your answer to this question of 5 halves times 2 is 5 with no fractional parts. Let's review and recap. What were the main mathematical concepts or ideas that you learned today? Great, thank you for sharing. And let's finish off. What do you think will be important to remember as you do the homework today? Wonderful. Thank you for taking the time to do this lesson. I hope you learned something new. If you need any help, please reach out to your teacher. Goodbye for now.